You wait 2 hours at a terminal just to spend 40 minutes in the air. You miss flights because of curfews, sit through weather delays, and spend more time waiting on the ground than actually moving. But what if that dead time, the hours you lose, could finally work for you? What if waiting became part of the plan? In 2026, Tesla believes it found the answer, not by flying faster, but by rethinking how time, access, and energy connect. This is the Tesla Super Electric Plane, a quiet revolution built around 4 shocks that could change regional travel forever. Stay with this breakdown, because once you see the first shock, you'll never look at a short flight the same way again. Most people think the biggest challenge for electric planes is battery power. But that's not the real issue. The real enemy is time. Every electric aircraft that came before Tesla ran into the same wall. For every hour it spent in the air, it needed 30 minutes on the ground. Plugged in, waiting, losing money with every passing second. Airlines hate that, because when a plane isn't flying, it isn't earning. And that's exactly where Tesla saw their opening. While everyone else was busy trying to build faster chargers or bigger batteries, Elon Musk asked a question nobody dared to touch. What if we never had to charge at all? And that's where the first real shock came in. Tesla designed something the aviation world had never seen before. A modular battery bay built right into the belly of the plane. When the plane lands, a robotic platform slides underneath, pulls out the drained battery pack, and swaps in a fully charged one, all in under 5 minutes. No waiting, no charging, just fly, land, swap, and take off again. It's the same logic behind Tesla's early experiments with car battery swapping, but scaled up and refined for aviation. Every swapped battery is automatically sent to a charging hub nearby, so by the time the plane finishes its next flight, a new battery is already ready to go. That single innovation changed everything. Instead of wasting hours between flights, Tesla's electric jets could operate almost nonstop, cutting downtime by 90%, and slashing operating costs like never before. But that wasn't the only twist. By moving all the heavy charging equipment off the plane and keeping it on the ground, Tesla made their aircraft lighter, cheaper, and easier to maintain. And with a subscription-based model called Battery as a Service, airlines wouldn't even need to own the batteries. They'd just pay for usage, swapping as often as they needed. For the first time ever, an electric plane wasn't limited by power. It was limited only by how fast it could turn around on the runway. But that was just the first shock. The second one, it would reveal how Tesla found thousands of hidden runways around the world, runways that no airline had ever noticed before. When people imagine airports, they think of giant terminals, endless lines, and expensive gates. But Tesla didn't. While traditional airlines were stuck fighting over the same few airports, Tesla looked somewhere nobody else was paying attention to, the forgotten ones. Across the world, there are over 5,000 small airfields, abandoned military bases, rural landing strips, even unused private runways, scattered like hidden gems across the map. To most companies, they were useless. Too short for big jets, too far from major cities. But for Tesla's new electric plane, they were perfect. Because Tesla's aircraft doesn't need a massive runway. It's smaller, lighter, and takes off faster than traditional planes, thanks to that modular battery system and ultra-efficient electric thrust. That means it can land almost anywhere. Suddenly, those forgotten runways aren't useless anymore, they're opportunity. Imagine flying from your local airstrip to another city in under an hour. No TSA lines, no endless waiting, no chaos. Just show up, board, and go. That's the kind of freedom Tesla is selling. Short-haul air travel that feels like calling an Uber. And here's the genius part. By using existing small airports instead of building new ones, Tesla cuts infrastructure costs to nearly zero. They don't need to fight for slots at major airports. They're creating a brand new network of Tesla air terminals, fast, automated, and fully electric. Each one equipped with robotic battery swapping systems, AI-managed flight scheduling, and quiet runways powered entirely by solar grids. This isn't just a plane. It's an ecosystem, one designed to turn every small airstrip into a piece of Tesla's global transport network. For decades, vertical takeoff has been aviation's holy grail, a symbol of futuristic flight that could lift straight from a parking lot. But reality hit hard. Hovering burns through power faster than any other phase of flight, especially when you're lifting tons of batteries. Most electric aircraft projects crashed into that wall. Tesla didn't. Instead of wasting energy fighting gravity, they decided to work with it. The Tesla super electric plane takes a smarter route, short takeoff and landing. Using distributed electric propellers along the wings, each motor adds lift and balance from the moment power flows. The result is a plane that needs only a few hundred meters to get airborne, small enough for thousands of regional airports that already exist. No need for new infrastructure, no massive vertiports, no hovering energy drain. Just clean, quiet, powerful thrust that feels like a glide. By removing the vertical element, Tesla unlocked range and efficiency that pure VTOL aircraft can't touch. Hover demands power. Short takeoff rewards smart design. NASA's X-57 research already proved how distributed propulsion increases lift at low speeds, and Tesla took that lesson straight into production. When each motor shares the load, the plane rises smoothly, cutting vibration and drag while delivering near-silent performance. On takeoff, the wing wakes up. Every propeller helping to lift, every kilowatt turned into forward motion, not wasted heat. That's the secret behind Tesla's regional advantage. It flies farther, faster, and cheaper using runways we already have. No waiting for new permits or construction. You could land at small-town airports that haven't seen regular service in decades and be back in the air minutes later. And because it avoids hover stress, the batteries last longer, maintenance cycles stretch further, and every flight feels effortless. It's a complete rethink of what electric flight should look like: quiet, simple, and ready for real passengers. The Tesla super electric plane cockpit feels more like a Tesla car than an airplane. No crowded buttons, no confusion, just 3 simple modes: economy, normal, and fast. You choose the goal, and the system does the rest. It adjusts power, lift, and battery use automatically to keep every flight smooth and safe. Behind that calm design hides a deep layer of intelligence. The aircraft constantly tracks weather, terrain, and nearby traffic to guide pilots with quiet precision. If something unexpected happens, the system can stabilize, reroute, and even land safely, proving that automation has finally matured. Every sensor collects data from each flight, helping engineers refine performance and extend safety margins over time. For pilots, it means less fatigue and more confidence. For passengers, it means smoother skies and trust in the machine that watches every variable. The goal isn't to replace humans. It's to protect them with clarity, control, and calm that never blinks. What truly sets the Tesla super electric plane apart isn't just its automation. It's how naturally it blends human and machine. Instead of fighting for control, the pilot and AI work as one team. The interface is built around instinct, clear visuals, minimal clutter, and real-time feedback that feels alive. Flight paths appear like glowing threads ahead of the nose. Weather zones pulse softly on the screen, and every motion of the control stick feels mirrored by the system's silent precision. The fly-by-wire design reacts faster than any human reflex, correcting turbulence before it's even felt. During descent, the AI balances drag and thrust to keep landings smooth, efficient, and nearly silent. And because every flight is logged in detail, Tesla's cloud learns from each trip, predicting issues before they happen. The more the plane flies, the smarter it gets, an ecosystem evolving in real time. This is where electric aviation stops being experimental and starts feeling inevitable. Every revolution in travel only works if the math makes sense. That's where the Tesla super electric plane quietly destroys the old rulebook. Traditional turboprops burn hundreds of dollars in fuel per hour and demand expensive overhauls every few thousand hours. Tesla skips that entirely. With only one moving part inside each motor and no combustion systems to rebuild, maintenance costs collapse. What used to require a hangar crew now takes a single technician and a tablet. The batteries, once a financial anchor, become a service, swapped, monitored, and billed monthly instead of bought outright. It's the same battery-as-a-service model that made electric cars scalable, now applied to the sky. Operators pay for usage, not ownership. That shift turns unpredictable repairs into steady, predictable costs. And when ground teams swap batteries in 5 minutes instead of waiting 30 to charge, the plane spends its day flying, not sitting. Every minute saved becomes a seat filled, a schedule kept, and a profit margin that grows. Even electricity itself costs a fraction of jet fuel, especially when charged off-peak from renewable grids. Add it all up, and the Tesla super electric plane doesn't just fly cleaner, it earns smarter. The sky has always belonged to dreamers. But for the first time, it might also belong to doers, engineers who think in electrons instead of engines, and visionaries who see silence as the new sound of power. The Tesla super electric plane isn't just another product. It's a statement. A promise that the future of aviation can be fast, clean, and breathtaking all at once. No smoke, no noise, just pure motion. Each takeoff becomes a symbol of what happens when innovation refuses to stop at good enough. The age of burning fuel is ending, and in its place rises something brighter, smoother, and infinitely smarter. The next chapter of flight doesn't begin in the clouds. It begins on the charging pad.